In our previous videos, we learned how to graph equations and explore them using the trace function. Today we're going to look at one of the most powerful features on the TI-84 Plus CE, the CALC menu. These tools can automatically find zeros, maximums, minimums, intersections, derivatives, and even definite integrals. Those are our features you'll use throughout algebra, pre-calculus, calculus, chemistry, physics, and engineering. Open the CALC menu. So to do that, we will second trace, which is CALC. Let's see what each option does. And we'll start with the easiest one, the value function. So the first thing we want to do is we want to turn our plots off. So second y equal, make sure all of our plots are off, which they are. Okay, let's set our window. So zoom, and we'll go down to zoom standard, which gives us a 10 by 10 graph. Okay, let's enter a function. So we'll say that y equals, we'll say x squared minus 4x plus 3. Okay, so let's see what it looks like. Okay, so a typical question would be the x value of 5. All right, so we can find the value by going to second calc. We're going to do value. We simply enter a 5. And that gives us the value that says when x is 5, then y is equal to 8. We can check that by substituting x equals 5. So y equals 5 squared minus 4 times 5 plus 3. So y is equal to 25 minus 20 plus 3. So y equals 5 plus 3. So y equals 8. Using the same equation, y equals x squared minus 4x plus 3, sometimes you'll be asked, where does the graph cross the x-axis? Okay, so we will go to second trace, which is calc, and then we'll choose number 2, which is 0. And what we need to do is the calculator needs to know which crossing of x that you want to calculate. Okay, so let's cursor over to, we'll do the left one first. All right, so I want to go on the left side of where it crosses. And then I press enter. Then I go to the right side of where it crosses. Press enter. And then it's going to guess by pressing enter again. And it's going to guess that x equals 1 or y equals 0. So we set our left boundary. So we marked it on either side. And then we pressed enter for it to guess. Now let's repeat for the second crossing here. So I'm going to go second trace, which is calc, 0. I want to cursor over closer to this boundary. Press enter. I'll move my boundary to the other side. Press enter again. Then we're going to ask it to guess. So it's going to say that x is 3 when y is 0. All right, so essentially what you've done is you just solved this quadratic equation up here. So you said that x could be equal to 1 or 3. Using the same equation, y equals x squared minus 4x plus 3, you're sometimes asked, what's the lowest point on the graph? All right, so what we have to do here is second, trace, which is calc. We're going to go to option number 3, which is the minimum. Okay, I want my guess to be pretty close. So I'm going to go ahead and zoom in a little bit. So I'm going to hit zoom, option 2, zoom in. I'm going to place my cursor, okay, in this area here, and press enter so I can see it up closer. Again, I want to define my boundaries just like before. So I'm going to minimum. I want to move my cursor to somewhere on the left side. Press enter. And I'll move my cursor to the right side. Okay, and press enter. And then press enter one more time. So when x is equal to 2, then y is equal to -1. Since the graph curves upward, we can find the minimum value. In many branches of science, math, and finance use minimums all the time. So just remember now that when you zoom in, your guess gets closer and closer to the accepted true value. So always keep that in mind. The next menu option we'll do is maximum. All right, so we'll need an equation where a parabola opens downward instead of upward. So let's go to y equals, and let's enter something like negative x squared plus 6x minus 5. Okay, I'm going to go ahead and set my window to standard. And let's see what the graph looks like. Okay, so we have a parabola which is opening downward. We'll do the same process as we did before. We now have a parabola which opens downward. We'll repeat the same process before. We'll define our left boundary, our right boundary, and then we'll ask the calculator to guess. So second, trace, calc. Let's go to maximum. Okay, we'll try it without zooming in. So I'm going to mark my left boundary. I'll mark my right boundary and press enter. And it says it's 2.99 whatever, which is 3 for my x, and my y is 4. So it's the same process as before. And for our next task, let's try number 5, which is intersect. Okay, so we'll need to define some new functions. So I'm going to say that x squared is going to be one function. And my second function, I'm going to say is 2x plus 3. I'm going to graph this. So I have two locations. All right, so we're going to have to give the boundaries for this first intersection, and then we'll find the boundaries for the second intersection. All right, so I'm going to zoom in a little bit. And put it somewhere close. Press enter. So I'm going to go second, trace, which is calc, number 5, which is intersect. Okay, I'm going to move my cursor close here. Press enter. And then somewhere here. Press enter again. Let it guess. So it's going to say the intersection is for x is -1, y is +1. Okay. All right, so to find the other one, let's zoom back out. Okay, and we want to find our intersection up here. And let's put our zoom in again. And let's get up close to that place. Okay, we're really close. So we'll say second, trace, or calc, intersect. So that's close. Then we do the other one. Press enter. We're going to guess. So it's going to give us the function that intersects at x equals 3 and y equals 9. Okay, this is very applicable to solving systems of equations. We have two or more equations you can solve for the intersects. In physics, you can do projectile motion. So this is a very useful function, intersect. Okay, the next feature is dy over dx. This feature is used in calculus and it estimates the derivative numerically. So let's say x raised to the third power minus 3x. Okay, a typical question would be, what is the slope when x equals 2? All right, I need to go back and change my window. So, what is the slope when x equals 2? Well, I can go second, trace, dy dx. I can enter a 2, press enter. And if you look carefully, it says dy over dx equals 9. So that will be the numerical derivative for x equals 2. Okay, an alternate method will be go to the math key, go down to number 8, which is n deriv. Okay, so I'm going to enter an x, the first blank. Then the second blank will enter our equation. So my y equals x raised to the third minus 3x. And I want for x equals 2. And press enter. And it gives me a 9 also. Okay, we could also solve this just using simple calculus. So if I use the power rule, okay, I can take this 3 and bring it to the front. So I have 3x. Now this will be 3 minus 1. Okay, this x is to the first power. So if I bring the 1 forward, it'll be 1 times 3x to the 0 power. So this cleans up to 3x squared minus 3. So for x equals 2, I could say that y is equal to 3 times 2 raised to the second power minus 3. So 2 and 2 is 4, 3 and 4 is 12, so that's 12 minus 3. So we can say that y equals 9. So we get the answer 9, which is the same as we got using the other two methods. The last menu option is number 7. This gives you a numerical integration. So if I go to y equals, let's clear that and say something simple like x squared. Okay. All right. So if I graph that, all right, so let's find the area beneath the curve from 0 to 2. So we can go to second trace, number 7. And I want to go from 0 to 2. So I press my lower limit of 0, press enter, my upper limit to 2 and press enter. Okay, you'll notice it shades in the region, which represents the area. So the answer is 2.666 repeating, which is 8/3. And if it's positive, that means it's above the x-axis. And if you have a negative value, if it's below the x-axis. Suppose car A has a 100-meter head start over car B. Car A travels at a constant speed of 20 meters per second. Car B starts from rest and accelerates at a rate of 4 meters per second squared. What time does car B need to catch the first car? Okay, so this is going to be a fun problem. So for car A, we're going to say that distance is equal to 100 plus 20 times t. Where distance is measured in meters and t is measured in seconds. All right, let's write an equation for car B. Okay, we know that the change in velocity along the x-axis is equal to the initial velocity times time plus 1/2 rate of acceleration times time squared. So the change in x is equal to, since it starts from rest, this is 0, plus 1/2 4 times t squared. So the change in x is equal to 2t squared. So here we have two equations now that we can use. So car 1, car A, and car B. So we'll say then that y equals 100 plus 20x, and we'll say y2 is going to equal 2x squared. So let's put those in our calculator. Okay, so back to the calculator. Let's go to y equals, and let's enter our equations. 100 plus 20x, and for the second one, 2x squared. All right, let's go to our window here, and I want my minimum to be 0. I want my maximum to be about 20. Okay, on the y's, minimum 0, and I'm expecting quite a large distance, so I'm going to put in a large number here, like 400. Okay, so let's graph this. So the blue line represents car A, which is going at a constant speed, and the red line will represent car B, which is accelerating. So if I want to get the time, okay, so I need to zoom in here and see where these two intersect. All right, so I'm going to zoom in. I'm going to cursor up here closer by. Press enter. All right, so this is the point. So let's go second trace, which is calculate, Let's do the intersection. So that'd be number 5. Okay, so I want to mark both lines. So I'm going to mark this one. Then I go up and mark the other one. Okay, and press enter. Okay, so it wants to guess. So it says the intersection is 13.66 seconds. And the distance traveled will be 373.2 meters. Okay, so from the calculator, we got 13.66 seconds and a travel distance of 373.2 meters. Okay, we can set these two equations equal to each other. Then I would have 100 plus 20x is equal to 2x squared. We can set this into a quadratic format. So this would be 2x squared minus 20x minus 100 equals 0. I can solve this quadratic equation. And when I solve for x in the quadratic equation, I get x is equal to, again, 13.66 seconds. Then if I take 1 my y equals, let's take the first one here. So 100 plus 20 times 13.66. Okay, again, I get 373.2 meters. So the answers check out. Another thing we could use is how fast was car B traveling when it intersected or caught up with car A. Okay, so we want to know how fast the car on the red line is going when it catches with the first car. Okay, so I'm going to go second, calc, and I want to do an instantaneous velocity. But an instantaneous velocity is where you draw a line tangent to a curve at the point that you're wanting the value of. And the slope of that line is called the derivative. Okay, something else we can solve for is how fast was car B traveling when it intersected or caught up with car A. So we want to know how fast he was going when it caught him. So to make things simpler, I'm going to go to y equals. I'm going to turn off this first plot here because I want the curve. So I'm going to turn that off so it's much simpler to see. All right, so we want the instantaneous velocity, or the velocity that the car was traveling when it caught up with the first car. So the instantaneous velocity is the derivative of that point. So I'm going to choose number 6, dy dx, and I'm going to enter for my value of x, 13.66. Okay, so my dy dx is 54.64. So that means he was traveling 54.64 meters per second when he caught the first car. And we can calculate that fairly easily because we know that the final velocity is equal to the initial velocity plus acceleration times time. So the final velocity is equal to the initial velocity, which he started from rest. He accelerates at 4 meters per second squared times 13.66 seconds. So the final velocity will give you 54.64 meters per second. So you can see then, instead of doing the math, you can also just graph it and get the same answer that way. Okay, here's a challenging problem. A projectile has the following equation. Ht is equal to negative 4.9 t squared plus 20t plus 2. When does it hit the ground? What is the highest point? What is the height at any time? And what's the vertical velocity at any instant? So I'm giving you the hints that I will use 0 to find the first one, maximum to find the next one, value, and derivative. So you can practice with this and kind of hone your skills a little bit. In closing, the CALC menu turns your TI-84 from a graphing calculator into a mathematical problem-solving tool. With just a few key presses, you can evaluate functions, you can locate zeros, find minimums and maximums, solve systems graphically, estimate derivatives, and calculate definite integrals. In our next lesson, we'll explore the stat feature and learn how to analyze functions using numerical data instead of graphs. Thank you for watching. If you found this video helpful, please be sure to check out other lessons on this channel. Please leave a comment, like, and subscribe. Thank you for watching.